Rotational inertia. When an object is rotating, it has rotational inertia. This is like regular inertia as defined by Newton's first law. Basically, inertia keeps an object in the state of motion which it is in, unless there is an external force acting on it. Rotational inertia, or moment of inertia, however, deals with objects which are rotating. Moment of inertia is similar in that it tries to keep an object in the same state of motion, but different because instead of dealing with a singular point of mass moving or not, now it is a whole object rotating about one point. The moment of inertia keeps the object rotating in the same plane rather than along one vector. That last point is why it is easier to stay balanced on a bike while moving. The two wheels with their rotational inertia do all the work for you. As you pedal to keep it going, you feed its moment of inertia. In turn, the wheel's desire to stay in the same plane keeps you upright. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The period of a pendulum can be expressed as t sub p equals 2 pi times the square root of L over g, where L equals the length of the pendulum and g equals the strength of gravity. As you can see, mass and amplitude are not part of the equation. This is because they do not affect the period. This equation explains why when the pendulum is shortened, it gets faster. As L in the square root of L over g gets smaller, the value of that expression gets smaller, causing the period to get smaller. And as the period equals 1 over frequency, as the period gets bigger, the frequency or number of times the pendulum oscillates grows, as is evident in the demonstration. It would be my pleasure. An elastic collision is a collision in which both objects remain separate after the collision, and the kinetic energy of the two objects is conserved. An inelastic collision is a collision in which the two objects stick together after the collision, and the kinetic energy is used to deform the objects. This demonstration is a combination of both inelastic and elastic collisions. It's elastic because the hand and face remain separate, but it's inelastic because the hand and face are both deformed.